May 2019 Supplementary Exam 11th question. Obtain the cascade and parallel realizations for the system function h of z as given here. The scheme of evaluation are parallel realization with a structure, block diagram or signal flow graph 5 marks. Then cascade realization with the structure, block diagram or signal flow graph 5 marks. So let us draw the block diagram. So in such type of questions, the final answer may not be unique, because for cascade form we can either select 1 plus 1 by 4 z inverse divided by 1 plus half z inverse, or we can select 1 plus 1 by 4 1 plus half z inverse, like that. Similarly, for parallel realization there may be changes. So let us try to solve this problem. So given h of z equal to the same expression, first we can do with the cascade structure. For cascade form realization, first we have to put it in the product form, that is h1 of z into h2 of z form. Here a further factorization is not possible, so we can take the second order equation as it is. 1 plus half z raised to minus 1 divided by 1 plus half, so it is 1 by 4. 1 by 4 z inverse divided by 1 plus half z inverse, then the second factor. Now we can realize in the using the second order form and realize it as a direct form, two structure form. Here we have one delay, then the A0 coefficient as minus half, then we have the B coefficient as half, 1 by 4. So this side we have 1 by 4, then summing point input here as x of n, this is the h1 of z. Now we can draw the h2 of z. So in the case of h2 of z, it is a second order system. So this is 2. So we have two delays are here. First delay, second delay, then we have the A1, A2 coefficients as minus half and minus 1 by 4. This will be minus half, this will be minus 1 by 4, and we have a summing point here. Output y of n. So this is the cascade form realization. Next we can realize the parallel form structure. Parallel form structure, h of z is given by this expression. Now next we want to decompose it into h1 of z plus h2 of z. For that we can apply here the partial fraction expansion method. Here this second order system which cannot be factorized with the real values, so we can put this as it is. So and here we can see that the denominator order is less than that of the numerator, so we can directly apply the partial fraction expansion as a by first term, then b is the inverse plus c by this term, because this is a second order polynomial. Now we can solve for a, b and c coefficients, c constants. So this is equal to equation. Now equate the numerator from which we can determine the constants a, b and c. So first for that we can cross multiply. So this can equate the numerator, we get in this form, which the constants can be equated and the coefficient of e raised to 1 can be equated and the coefficient of e raised to -2 can be equated, so that we get a plus c equal to 1. When we equate the constants, then we get the coefficient of z inverse, we get this term. Then we get the coefficient of z raised to -2, we get this term. This we can rewritten as a plus 2b plus c equal to 1 by 2, a plus c equal to 1. If you are subtracting 2 from 1, we get b equal to -1 by 4. So once you know b, a can be easily computed. A is obtained as a equal to 1 by 2. Similarly, we can determine c as, so these are the constants. So once we substituting the constant, we get the partial fraction expansion. Substituting, we get this. Now we can realize this structure. We have the two delays, then the coefficients -half, -1 by 4. Now the b coefficients 1 by 4. Here the b0 coefficient half. So we have the two structures which we have to connect in parallel. You can sum either here or here. The output will be y of n. Here we have the input x of n. So you have connected the two structures in parallel form. So this is the final structure. So we have solved the problem. So let us have a quick review on this problem. So given the system function h of z, first we have draw the cascade structure, or we have put this h of z in say product h1 of z and h2 of z. Then we have realized the cascade structure independently with h1 of z and h2 of z, then connected in series. This is the cascade realization. So you'll get 5 marks up to this point. Then we have the parallel structure. When the parallel structure is given by the H1 of plus H2 of Z. So we have to apply here the partial fraction expansion method. Here the denominator order is higher than that of the numerator. We can apply the partial fraction, and also this second order polynomial is not able to factorize in real numbers, so we can apply in this form. Then getting the numerators are solved for the constants a, b, c. Then substituted for this one, and we have drawn the parallel structure.